So we're going to look a little bit here at velocity time graphs and really go over those interpretations that we can get from our velocity time graph. Now, a velocity time graph is just that. We have velocity on our y-axis, we have time on our x-axis. So what it measures is how does the velocity change over time. In our constant velocity model, when we started out talking about constant velocity, what we had was something similar to this. When we plotted that change in position over time, what we found was that the velocity didn't change. We would get a graph that looks something like this. Now what this means is, let's just say this is number 3. I don't know, we'll just make that number up. So we're in a positive 3. So here's 0, 1, 2, 3. At 0 seconds, our velocity would be 3 meters per second in the positive direction. At time 2, we would be 3 meters per second. Time 4, we're 3 meters per second. Time whatever, we are 3 meters per second. So all of those mean that the velocity does not change. So our change in velocity for this graph right here is 0. If we were to find the slope of this graph, we would find it to be 0. Because slope is rise over run, there is no rise. The change in velocity is 0. The rise in velocity is 0. So our slope equals 0. So the slope on our velocity time graph is equal to our change in velocity. Now we have defined change in velocity as acceleration. So if the change in velocity is 0 and the slope of our velocity time graph is 0, our acceleration is 0. So this whole time our velocity is a positive 3 meters per second. Now that's kind of important. This whole section right here, if you have a line in this part of the graph, in the positive region of the graph, when we say positive region, what we mean is anything above the x-axis. Okay, that positive region. What this means is that we have a positive velocity. Now, positive velocity means that we are moving in a positive direction. That's what that means. So this line right here, even though we're not changing, even though we don't have any change in velocity, it's in the positive region of our graph because it's above the x-axis. That means it has a positive velocity, which means we are moving in the positive direction. We can look at that in our negative direction as well. Let's go down here to negative 3. If we draw a line just like this, in our negative 3 meters per second, the same thing. What we have is negative 3 meters per second along this whole point. Our velocity doesn't change. Our slope is 0. Our acceleration is 0. The only difference is now we are in this negative region of the graph, which is anywhere below that x-axis. Ooh, we're getting kind of close there. X-axis. This is a negative velocity. When we have a negative velocity, what we mean is we are moving in a negative direction. Okay. So when you look at a velocity time graph, if the line is in this section, this positive region of the graph, it's a positive velocity and we're moving in a positive direction. If the line is in this section of the graph, this negative region of the graph, we have a negative velocity and we're moving in the negative direction. Now we can take that and we can apply that a little bit more. So what if we have a line that looks something like this? Okay. So now what we have a velocity that is changing. At this time, the velocity is here. At this time, the velocity is a little bit higher. Here it's a little bit higher. So as we move along this line, our velocity is increasing. It is still in the positive region. So what we have is we have a positive velocity, which means it's moving in the positive direction, but it is getting bigger. It's moving away from 0. When we look at this slope, the slope is moving away from 0. This means that the magnitude is getting bigger. So as we move away from 0, we increase the magnitude. If we are increasing the magnitude of our velocity, we're speeding up. So our velocity is increasing in the positive direction. So our velocity is getting bigger, and we're moving in a positive direction. Okay, so when we look at this line, we are in the positive region, which means we have a positive velocity, which means we are in the positive direction. Our slope is moving away from 0, so we're increasing our magnitude, which means we're speeding up. Now we can do the same thing. We can have a line that looks something like this. We're still in the positive region, so we still have a positive velocity, but our slope is moving towards 0. So that means our magnitude is getting smaller. So as we move from a higher velocity down to 0, the magnitude of our velocity is decreasing. So our magnitude is getting smaller, so we are slowing down. So this velocity is decreasing in the positive direction. What if we've got our line down here? We're in the negative region of our graph, which means we are moving at a negative velocity, which means we're moving in the negative direction. The slope is moving where? Here's 0. Our slope is moving towards 0. So our magnitude is getting smaller. We're starting at a high velocity. We're moving towards 0. We have a decreasing magnitude. So we're slowing down. So our velocity is decreasing. The magnitude of our velocity is decreasing, but we are still moving in the negative direction. So then if we have something like this, we're still in the negative region, so we still have a negative velocity. We're still moving in the negative direction, but our slope is moving away from 0. So we start closer to 0, our magnitude increases. So if the magnitude of our velocity increases, we are speeding up. So we have an increasing negative velocity. All right, so in this positive region, we have the slope away from 0. Our slope is getting bigger in magnitude. Our velocity is increasing in magnitude. We're speeding up in the positive direction. In this case, we are slowing down. Our magnitude is getting smaller in the positive direction. So we have a decreasing speed, decreasing velocity in the positive direction. Down here in the negative region, we have a negative direction. So as we are getting closer to 0, we're decreasing the magnitude. The velocity magnitude is decreasing, so we're slowing down in the negative direction. Here we're sloping away from 0. So we are increasing the magnitude of our velocity, so we're speeding up in the negative direction. Now let's look at that acceleration a little more closely, because we know that acceleration is a change in velocity. All right, that's how we define acceleration. And so this change in velocity is what we're actually measuring on this graph. So the acceleration can be found on a velocity time graph by finding the slope, the value of the slope of the velocity time graph. Now we know that slope is rise over run. That's how you determine the value for the slope. So when we talk about rise, we're talking about change in velocity, and the run, we're talking about change in time. So acceleration is equal to delta V over delta T. So we're going to make up some numbers here. This is not to scale, but let's pretend it is. Let's just say that we go from 0 to 10 meters per second on this particular slope. So we're looking at this slope right here. And let's just say that we go from 0 to 10. In order to find the acceleration, let's call this line 1. The acceleration of line 1, we're looking at delta V over delta T. And so remember, delta is final minus initial. So we have 10, positive 10 minus 0. So we end up with a positive 10, let's just say in 1 second. So we have a positive 10 meters per second. So this would be the acceleration for this line. Now if we look at this line, let's just say these are all the same. Pretend with me here. So we start at 10 and we end at 0. So for line 2, we're going to do the same thing. We're looking at delta V over delta T. In this case, we start at 10 and we go to 0. So final minus initial is 0 minus 10. So in this case, we have a negative 10 over 1, which is negative 10 meters per second. Do the same thing with line 3. So line 3, delta V over delta T, final minus initial. We started at negative 10, actually. So we started at negative 10, we ended at 0. So 0 minus negative 10 is a positive 10 over 1. So we have a positive meters per second. And then 4, let's go 0, negative 10, delta V over delta T. Final minus initial, we have negative 10 minus 0, so we have a negative 10 over 1. We have a negative 10 meters per second. So what this tells us, in this case right here, in the slope of 1, it tells us that we have a positive acceleration. In the slope of 3, we have a positive acceleration. But wait a minute, because if we look at this first one, we were speeding up. But if we look at this first one, we were slowing down. So how is it that you can have a positive acceleration in one situation and be speeding up, and a positive acceleration in another situation and be slowing down? Well, that doesn't make sense, does it? Well, let's look at this a little bit. So what we've got here, well, let's put this on here. So what we've got here is a positive acceleration. Here we have a positive acceleration. Here we have a negative acceleration, and here we have a negative acceleration. So it might be kind of helpful to view this in terms of a motion map. So let's draw this out and see what it looks like. If we look at line 1, we have a positive velocity. It's moving in the positive direction and it's increasing. So we're increasing at a constant rate. So what that means is if we were to draw vectors for that velocity, then those vectors would be getting larger as we went along. So we're going to define positive to the right, just to keep this simple. So positive is going to be going from this direction to this direction. And we're just going to come down and draw some vectors. I don't know, a couple of them. So the first vector is however many long, but the next one is going to be a little bit longer. So let's just draw it 2 longer every time. Okay. So in the first second that we move, or first time period that we move, we're moving at some velocity. In the second time period that we move, that velocity is increasing. So the vector is larger by 2. Now we have a constant velocity. So every vector that we draw after this is going to increase by 2. Okay, so our velocity is increasing as we go across. If I can count. 1, 2, 3, 4. We'll stop there. Okay. So for each time period, our velocity is increasing by 2 squares each time, 2 units of velocity each time. Now the difference in length of the velocity vectors is the change in velocity. So we have had a change in velocity in this positive direction because our magnitude has increased and we are going in the positive direction. And we have also defined the change in velocity as acceleration. So since acceleration is also a vector, we could represent that with our vectors as well. So the difference between here and here is 2 squares. So for this time period here, our acceleration was a difference between this vector and this vector. For this next time period, it was another 2 squares. So our change in velocity increased in this direction. Same thing for our last time period. Our change in velocity was 2 squares in this direction each time. So this shows us that our acceleration is constant. Okay, this is our change in velocity. Our velocity has increased by 2 each time. And so our acceleration is 2 to whatever as we move along. So let's look at our other velocity in the positive direction. Okay, so since it's in this section up here, we're still going to be moving in this direction, but our velocity is getting smaller. So this is our velocity for 1, this is our acceleration for 1. So our velocity for 2, it starts out high. We'll just pretend that's all the same number here, and we'll go 8 to start with. Okay. So this right here, we start out with a high velocity, but as we move along in our time, our velocity gets smaller. So when we draw our velocity vectors, every time we draw them, they're going to get shorter. So the magnitude of our velocity is decreasing. Our direction is still the same, but our magnitude is decreasing. Okay. So what this means is our acceleration is going in the other direction. Our velocity is getting smaller. So if we go back to that whole graphical analysis of our vectors, up here, if we take this vector and add it to this vector, we have 2 here and we have 2 here, we're going to get that one. So then that's our change in velocity. So we have this velocity, it changes by this much, so we get this. This velocity is going to change by this much, so it's going to be bigger. This velocity is going to change by this much, and it's going to be bigger. In this case down here, for our acceleration of our second line, if we look at the difference between this one and this one, it's shorter. So our acceleration is going to be in the opposite direction. So I'm not sure where to draw this. Let's go here. So for these 2 time periods, this vector is shorter than this one. So if we add this one to this one, we actually subtract because they're going in opposite directions. So our acceleration will be going in the opposite direction of our motion. Same thing here. From here to here, we have a decrease of 2. From here to here, we have a decrease of 2. So our acceleration is constant. It's still 2. So the magnitude of our acceleration here and the magnitude of our acceleration here is the same. They're just in opposite directions. So if we're moving in a positive direction, and we're increasing in magnitude, we have a positive acceleration. So since our arrows are going this direction, okay, we're going in the positive direction, we have a positive acceleration. In this case, we have a positive direction velocity, but it's getting smaller, so we're slowing down. So our acceleration then will be negative. So in this situation, our vectors are going the opposite direction, so we have a negative acceleration. So then if we look at line 3, okay, line 3, we are decreasing in velocity. We're in this section of the graph, so we have a negative velocity. So our velocity is going in the opposite direction. It's going in the negative direction, but it's getting smaller because it's going back towards 0. So for this one, let's just start over here because we're going in the negative direction. Okay, we're going to start out big. Okay, we're going to start out with a large magnitude, and that magnitude is going to get smaller and smaller. So we're going to start out over here with a large magnitude, 1, 2, going in the negative direction. So we have a negative velocity going this way. And as we move across, it's going to get smaller. We'll just keep everything constant here. Make things simpler. Okay. So over the same amount of time, that one's just like this. We're getting smaller with our magnitude, smaller with our vectors. We're just going in the opposite direction. So our acceleration then for this one, since this one is smaller than this one, we would have to add an arrow, a vector, in the opposite direction. So in this case, we have an acceleration going this way. So when we add this one and this one, we're actually subtracting it. We're chopping it off because they're in opposite directions. So when we take this and we chop it off with this one, we get that one. So the same thing here. If we go from here to here, we have a negative acceleration. Well, negative with respect to that. It's an opposite acceleration, maybe is a better word to say. Okay. It's actually a positive acceleration because it's going in the positive direction. So this is where it kind of gets weird, is when we start getting these positives and these negatives. So this velocity 3, we're going to start somewhere, and we're going to go in the negative direction. So we're moving to the left, we're moving in this negative direction, but we're slowing down, so our velocity vectors are getting smaller, which means that our acceleration vectors have to be going in the opposite direction. So when we're slowing down, the acceleration is in the opposite direction of the motion. We're slowing down, our acceleration is in the opposite direction of the motion. Here we're speeding up, so our acceleration is in the same direction. So if we come back and we look at number 4 then, space there, if we look at velocity of the 4th line, in the 4th line, we are still moving in the negative direction because we're in this section of our graph. We're moving in the negative direction, but we start out with a low velocity and it increases. So we're going to start over here in the negative direction and go this way with a small velocity, and we're going to increase that velocity as we go across. So we're going in the negative direction, but with an increasing velocity in that way. So since we're speeding up, the acceleration is going to have to be in the same direction. So if we take this one, this vector here is smaller than this one, so we have to add something to that vector. So our acceleration is going to be in that direction. Same thing here. In order to get this vector from that one, we have to add, which means our acceleration has to be in the same direction as the motion. And so what we have here is we have a negative acceleration. So we can have positive acceleration in 2 different situations. We can have a positive acceleration when our velocity is increasing in the positive direction. We can also have a positive acceleration when our velocity is decreasing in the negative direction. Okay, both of those are positive accelerations. The positive only tells you the direction of the acceleration. Okay, so the acceleration is in the positive direction. The acceleration is in the positive direction. A negative acceleration can occur when we are decreasing velocity in the positive direction. So our acceleration is in the opposite direction of the motion. We can also have a negative acceleration if we are increasing velocity in the negative direction.